Welcome students to our next session of dynamic programming problem under operation research. Myself Piraj Majumdar, I welcome you to my YouTube channel Mechpro classes. Today we will have the stagecoach problem under dynamic programming. Okay. Previously we have completed the introduction part of dynamic programming. Any one of you who haven't yet seen the previous video on the introduction of dynamic programming, I suggest you to go to the video and have a look. Okay, so that it will make you more easily understand the different terms associated with dynamic program as well as stagecoach problem. Okay, now let us start stagecoach problem. We have this stagecoach problem and as well as knapsack problem under dynamic programming in your syllabus of mechanical engineering. Okay, now look, previously we learned that Bellman was the man behind the dynamic programming, the founder of the dynamic programming, and we also learned the Bellman's principle of optimality. Okay, so you already know, but just to remind you that an optimal policy has the property that whatever the initial state and the initial decisions are, the remaining decisions must constitute an optimal policy with regard to the state resulting from the first decision. Okay. Now, without any introduction and coming to the directly into the problem, stagecoach problem. So, let us know what this actually means, this stagecoach problem. Now, you will have a question in your mind, what does this particular stagecoach means? This stagecoach is a cart, or you can say a large horse-drawn. Previously it was used, now it is obsolete. It was very famous, this stagecoach in Americas. It was a very large horse-drawn vehicle, you can say also. Okay, or you can say cart. Somewhat this one, say it has got two wheels. It was having at least four wheels, and behind that it comprises say this one type of cart, and it was been moving by a by a horse, you can say. Okay, so sorry, I am not so much of a painter, you can say, but I'll just give you an idea so you can have a sorry for my drawing. So the cart, you can say, this type of cart was previously known to be a stagecoach. Okay, now this stagecoach, or you can say horse-drawn vehicle or cart, this used to carry passengers, often male also, along a regular route, okay, between two places, say this place and this place. Okay, now coaches, these are the coaches. Okay, so you can say coaches that carried passengers become known as stagecoaches. So stagecoaches are those coaches which were carrying passengers. Okay, from that only you can say the term coach is applied to the nowadays railway engines also. Okay, that is the coaches which carries the passenger. Okay, now they have to stop to rest at stages along the way for for taking rest, okay, for foods, okay, so many things. Now, until railroads appeared, early travelers in America made long distance journeys either horseback or in horse-drawn coaches. This one, okay, are called as stagecoaches only. Okay, now where from this particular problem arrived, the history. Now the history or the background behind the stagecoach problem goes in the way, somewhere, sometime, a long time ago, A fortune seeker in Missouri travels to California by stagecoach to join the gold rush through unsettled country. Unsettled means where there lies chaos. Okay, there lies different conflicts, or there is a security issues, you can say. Okay, that is the unsettled country of serious danger. Okay, now although his starting point and destination were fixed, he had a lot of choice in his route of travel. Being prudent to consider safety, what I was talking about, he found out that the safest route should be the one with the cheapest total life insurance policy. Now, it is because the cost of policy must have been worked out after careful evaluation of the safety of every run of the stagecoach travel. Okay. Now, from this story, actually the stagecoach problem arrived. Now, let us move directly to the stagecoach problem, which you are going to face in your semester examination. Now, this was the whole network. I am just drawing the alternatives, or you can say the routes. So, from A, say this is the source. Okay, in the given problem, this is the source, and say this is the destination. Okay, now the alternatives are these routes, you can say. Okay, now let us see what the costs of this particular routes. Okay, now this is the complete network diagram, or you can say the graph. A is your source and J is your destination, as you can see over here. And the alternative routes are from A to B, A to C, A to D. And from B you can see to E to F. From C it is also E, G. Similarly from F to H, I, and H and I to J, you can say. Okay. Now if you carefully look these numbers 2, 4, 5, 7, 4, 6, 3, 2, 4, 4, 1, 5, 1, 4, 6, 3, 3, 3, and 3, 4. This say gives you the traveling cost or transportation cost as well. Which means if you have to travel from A to B, you have to pay ₹2 for the time being, say. Okay. For say if you travel from A to C, you have to pay ₹4, say. Or if you travel from A to D, you have to pay ₹5 as well. Now, first I will discuss the greedy approach with you. In the previous video, in the introduction video, I already discussed the greedy method, or the approach of greedy method, how it differs from dynamic approach or dynamic programming approach. In this stagecoach problem, I will also show you the greedy approach, and side by side we will solve this particular graph or network with the help of dynamic programming as well. Okay, so let us start with greedy approach. Now, the greedy approach means it is greedy about something. So I will write greedy approach. Now, if I say it is greedy about, say, the cost of travel. Okay, so it will choose the path with the least cost. And from A to B, you can see over here, it is only 2. Cost is only 2, as you can see. So the greedy approach will just take this path and will omit the rest of the paths as well. So it will start from A to B. So it will move from A to B as well. Okay. Now from B, it will only choose the, least cost path. Now you can see this is 7, this is 4, this is 6. So it will choose from B to F. Okay. And it will omit the rest of the 2 paths. It will just overlook rest of the paths, and it will move to the least cost path as well. This is the greedy approach. Now from coming to the F, it will again choose in the similar way. From F you can see we have 6 and 3. Okay. So it will choose the 3 path. There is a path which is having cost of transportation as 3 only. Okay. Next from F to I, it will move to J. It is only one path, so it will follow this path only. Now calculating the greedy path approach, the cost I can write for greedy path approach, I can write the least cost or the cost of transportation is 2 plus 4, 2 plus 4 plus 3 plus 4, which gives you 4 plus 2, 6 plus 3, 9 plus 4, 13. So greedy approach, applying the greedy approach. Now look, stagecoach problem is, our aim in this stagecoach problem is to, starting from source to reach destination, we have to find, I can write it over our aim. In aim, I can write our main aim in stagecoach problem is to find, say, the optimal route, or you can say the shortest route as well, or you can say the route with least cost, you can say. Okay, so this is our aim, you can see in stagecoach problem. Now applying this greedy approach, we can find the cost of the travel is, or the transportation cost is coming to be 13. Now we'll approach in a dynamic way. That is a dynamic program we will apply to solve this particular stagecoach problem. Now applying dynamic problem, we have to make this or you can say, you can write these costs or the alternatives in a matrix form as well. Okay, it will help you to formulate the problem very easily. Now look, from A to B we have got value 2, from A to C we have got value 4, from A to D we have value 5. Okay, now from B to E, you can see B to E it is 7, and from B to F it is 4, B to G it is 6, and from C to E it is coming 3, C to F it is coming 2, C to G it is coming 4, D to D to E it is 4, D to F it is 1, and D to G it is 5. Similarly, you can calculate from E to H it is 1, E to I it is coming to be 4, from F to H it is 6, from F to I it is 3, and from G to H it is 3, as well as G to I it is also 3. Now from H to J it is 3, I to J, sorry, this one will be I to J it will be 4. So this is the breakup of the or you can say the matrix form of the given dynamic problem, or the stagecoach problem as well, you can say. Now we have to make a okay, you can say A is a starting city, you can write, and J is the destination city as well. Okay, now BCD, you can say BCD, you can say stage 1 cities. This is stage 1 BCD, this one you can say this is the stage 1. Okay, you can write it over here. You can write it as stage 1. Okay, so this is the stage 1, and EFG, you can say this as, we have to know, already in dynamic problem we have to break the main problem into the various stages or sub problems, you can say. So these are the stages. So stage 1 is BCD, you can say this is the stage 1. Now this will be the stage 2. EFG will be stage 2 cities, and as well you can say HI are the this one will be stage 3. So this will be your stage 2. Okay, so I can write stage 3 cities, I can write. Okay, now we have to find the smallest shortest path. Now we have to develop a recursive relationship. I already told you in the previous class of the introductory class of dynamic programming that parent of this dynamic programming is a recursive or recursion, you can say. It is also known as the recursive optimization as well. So our main aim or main step or motto, you can say, in dynamic programming, we have to first break the problem into sub problems. Then we have to find the recursive relationship, or we have to make a recursive relationship out of this problem. Okay. Now let us see how to form the recursive relation for this particular stagecoach problem. Look, for stage n, okay, for stage n, say we have Sn and say we have got Sn plus 1. Okay. Now say this is the Xn. Now I can write contribution of Xn equal to ds Xn. I can write. Now value of say Fn s comma Xn, I can write ds Xn plus f of n plus 1, that is a star of Xn. In the previous video we already discussed about this recursive relationship as well. If you find anything problem or doubt, you can comment, or you are welcome to see the previous video on the introduction part of the dynamic program, where we have learned a lot of things regarding this recursive relation. Now next step is to find Fn star of s. How to? This one, by finding the minimum of say Xn, that is ds Xn plus f of n plus 1 star x of n. I can write. Now this f of n, I can say s of Xn. This is the distance of the best overall policy for the remaining stages, given a run from state S, okay, ready to start stage n with immediate destination Xn, you can say. And this ds Xn is the distance from state S, this one, to immediate destination Xn, this one, okay. Now Fn plus 1 star Xn is the optimal distance at the previous stage with this Xn, okay. And Fn star, this one is the corresponding minimum value of Fn s comma Xn. Look, this is the recursive relation, okay. You might be finding a little bit difficult. You will be finding that it will be very much difficult to solve this stagecoach problem with this recursive relationship. I can assure you that when I am going to solve this problem, you will find it very easy. Okay, just stick to the last of the video and we'll have very much fun while solving this particular. This is a very interesting problem, I can say. Okay, so I have made a space around here to solve the problem using dynamic programming approach. So I have drawn the network over here. The same network I have drawn over here. It might look somewhat congested, but I will help you reading the values. You just only need the values for the alternative routes for solving this particular dynamic problem. That's all. Okay, now let us see how to solve this problem. Okay, so previously we have found applying greedy method, you can say, by greedy method the cost is coming around to be 13. The value is 13. Now coming to this DP approach, I can write it as DP approach. That is a dynamic programming approach. Okay, we'll start from jth node, that is this one. Okay, and we'll move towards this line. Okay, this method starting from, you can write start from jth node. Okay, it is known as, you can know, backward technique. We already have discussed in the first video what is forward and backward techniques as well. Now we'll solve this problem using backward technique. Okay, let us see how to solve. Let us say we are starting from this particular J node. So the cost of travel for this one, I can write it as starting from J, cost of travel. What will be the cost of travel? You already know. F of J will be 0, as because we have to reach here, so cost of travel is 0. Now we have to calculate F of H, that is this one and this one as well. First let us calculate F of H. Okay, now to calculate F of H, from H to J, it is already given. Only one root is here, that is 3. That is obvious. So you can just write it as F of H is equal to 3. Similarly, for F of I, only one root is available. So you can just write it as F of I. We are using the recursive relationship as well. Okay, it is 4. Now we have to find F of E. These are the, these are the substages. This one is a substage, this one is a substage, this one is a substage. So we have broken the problem into substages. Now we'll find the values at each stage. So now to find F of E, look, to find F of E, we have developed a recursive relation as well. Now we'll apply this recursive relation. To find F of E, it is given by minimum of 1 plus F of H, comma 4 plus F of I. Okay, look, we have to find F of H, we already know as 3, and we know F of I as 4. Okay, now you might be wondering where from this 1 and 4 has arrived. Look, this is E node, you can see. Now from E to H, how much is the cost? That is 1. And from E to I, what is the cost? That is 4. So recursive relationship says for finding the function of E, we have to calculate the minimum of 1, that is the E to H cost, 1 plus F of H, that is we have already found it. And also there are, as because from E we have got two alternatives. The second alternative is 4, that is the cost of traveling from E to I is 4. So we have to calculate 4 plus F of I as well. Now from these two values we have to find the minimum, that will give you F of E. Okay, now I think it is clear. If you are again having some problem in this particular recursive relation, you can comment me in the comment section as well. Now say minimum, I can again write 1 plus F of H is 3 given over here, comma 4 plus F of I, that is 4 plus 4 I can write. So it will give you how much? 4, 8. So it will be, what is the minimum? That is the 4. So I can write 4. So F of E you can write as 4. Now next we have to calculate again F, G, B, C, D as well. Okay, let us calculate. Now F of F, this one from F we have got two alternatives, that is this one F of H and F of I, you can see. Now we have to calculate this, the value that is given F of H is 6. Okay, and from F to I that a value is given is 3. So 6 plus F of H and 3 plus F of I, you already know. So I can write 6 plus F of H, that is 3 given over here, and 3 plus F of I, that is 4 given over here. So I can write it similarly. Now minimum of these two, 9, 7, that will be coming 7 only. So F of E you have to write as 7. Similarly I will calculate for G also. Okay, now for G I can write minimum of 3, as you can see, G, both values are 3 from G to H and G to I as well. So I can write f of G equal to minimum of 3 plus f of H and 3 plus f of I as well. Okay, so it will give you how much? 3 plus 3, and 3 plus 4 as well. So it will be, 3 plus 3, 6 and 7 as well, which will be coming out to be 6. Okay, so you can write f of G as 6. Now look for B. We have got 3 alternatives. One is 7, another that is the B to E is 7, B to F is 4, and B to G, that is 6 given over here. So we'll write for function of B, we have minimum of 7 plus f of E, this one B to E, comma how much? 4 plus f of F, I can write, comma 6 plus f of G, I can write. Okay, so this one 7 plus f of E, 4 plus f of F, that is 7, 4 plus 7, and 6 plus f of G, that is 4 plus 6, or 6 plus 4, whatever you can write. So it will give 11 and 10. So you can write 10. Okay, so I am having some problem, I think. So I have mistaken over here. It is 6. Look, this is the 6. 6 plus f of G. So it will be 6. So 6 plus f of G. F of G is coming out to be 6. So 6 plus 6, it will be 12. So the minimum value will be, 11. Okay. So you can write f of P as 11. Okay. Now let us calculate the latter one. For C we can write how much this value. C we are having 3 and then 2 and then 4. So we can write 3 plus f of E, 2 plus f of F and 4 plus f of G. So we can write 3 plus f of E, comma 2 plus f of F, okay, and 4 plus f of G I can write. Okay, now this will give 3 plus 4, f of E you already know 4, and f of F you know that is 7. So you can write 4 plus 7, sorry, this will be 2 plus 7, comma 4 plus f of G. F of G is how much? 6. Okay, that is 6. So minimum of you can write 7, 9, 10. So that will be coming around 7. So f of C you can write as 7. Now for finding f of D, we have got D, 4 plus f of E, 1 plus f of F and 5 plus f of G. So I can write for D minimum of 4 plus f of E, comma I can write 1 plus, this is 1 plus f of F and 5 plus f of G I can write, 5 plus f of G I can write. So this will give you how much value? 4 plus f of E you already know, that is 4, 1 plus f of F, 1 plus f of F, that is 1 plus 7, and 5 plus f of G, 5 plus f of G, that is 6. Okay, so how much? 8 and 11. So minimum will be 8 only. So you can write f of D is coming to be 8. Now for f of A we have got, look, 2 plus, I can write it again. We have got 2 for this one, this is the node, starting node, that is the A. So we have got 2 plus f of B, 4 plus f of C and 5 plus f of D as well. Okay, so we'll write 2 plus, for finding f of A we have got minimum of 2 plus f of B, 4 plus f of C and 3 plus f of D. Okay, now 2 plus f of B, f of B is 11, so I can write 2 plus 11. Okay, 4 plus f of C is 7, so 4 plus 7 I can write. 3 plus f of D is 8, 3 plus D I can write. So it will give you 13, 11 11. So minimum will be how much? 11. Okay. So you can write f of a is how much? Coming to be 11. Okay, f of a. Now we have got all the values. Now we have to find the optimal root. Now optimal root from this calculation you can see very easily. Now look, the optimal root is a d f I j. Why? As because you can see the optimal value is coming to be 11 starting from a and ending to the j. In which root? In this root. How can you find? Look, from this root a d, f, then f, and then I, this one I, and then z. From this subset of the problems you can see that the value of the optimal will be 11 only. Then you have to find the root. If you calculate this root starting from this one, a to d, then d to g, then d to f, that will be d to f, then f to I, f to I, then I to j, this one. If you find this root, the cost becoming 5, plus 1, 6. From greedy approach previously, when we applied the greedy approach to solve this shortest root problem, we are getting 13 value. Okay. Now applying DP, that is the dynamic programming approach, breaking the problem into sub problems and then formulation of the recursive relation and applying that recursive relation to find the shortest root, we are finding the optimal solution is coming to be 11. Say this is the cost of travel, you can say. So optimal value will be 11. Now we have to find the optimal root as well. Now if you start from this root, this will not be 5, sorry, this will be 3. We already write it as 3. Look, this is a 3, so this will be this value will be 3. Okay, so if you say, if you are moving in this route from a to d, then d to f, then f to I, and then I to j, this route you are following, you can find by hit and trial method, but your value should be 11 only. Now if you say 3, a to d is 3, d to f is, this one is 1, so plus 1. Now f to I, this one is 3, so you write 3. I to j is 4, this one is 4, so you can write 4. 4 plus 3 7 plus 1 8, 8 plus 3 gives you 11. So you can see you have to find the root, but you can apply this DP approach to find the optimal solution as well. Now when you find the optimal solution, it will be very easier to you to find the optimal root, which will cost you the same amount which you are finding by applying the recursive relation in a DP approach for this particular stagecoach problem. Now you can see, easily compare how efficient this dynamic programming is. We cannot apply this greedy approach to solve this particular network, or you can say a bigger network or graph, you can say as well. So we have to apply this for this stagecoach problem, the dynamic problem, which breaks the graph or the problem into sub problems or stages, you can say. These are the stages: stage 1, stage 2, stage 3. So after breaking the main problem into different stages or sub problems, we have to find the recursive relation. This one is the recursive relation. After formulation of this recursive relation, you have to find the functions of every stages or states. This is the states, B, C, D are the states. So you have to find the value of the recursive relation of the states, state variables. These are the state variables. After finding the state variables, you will find the optimal solution at the starting point. Okay. So our main objective is to find the optimal solution or the optimization. Okay. So by applying DP, we are finding this as 11, where in greedy approach that was around 13. Okay. So this is all about the stagecoach problem, and this is very important for your exam purposes in semester examination as well as in your competitive examinations. So I hope you have enjoyed the session and you have a clear understanding and you have a well confidence to solve this type of problems in your examinations. And if you still have any confusion or doubt left, you can still comment me or you can contact me. My phone number is given over in my channel Mechpro classes. Stay safe and stay healthy, and please watch my next video on knapsack problem. Okay, thank you for watching. Thank you very much.